ROXAR multiphase meters measure oil, gas and water in flow lines in real time without any need for separating the phases first. ROXAR has developed meters that cover the full range of gas-void fractions, from water cut meters at the low end, through non-gamma, gamma and high gas meters, all the way to wet gas meters at the high end. We supply portable metering skids for well testing and special models for subsea applications. Here's a ROXAR subsea multiphase meter. The CPU and power controls are packed into a retrievable canister in the guide you can see on the left. Let's take a closer look at a ROXAR multiphase meter. We start with a spool piece, that is a section of pipe that will be installed as part of the flow line. At the top end we have a Venturi meter. Below that we have a gamut of detectors that measure electrical and physical properties of the fluid mixture that will flow through it. The detectors are duplicated to provide redundancy. Flow computers process the duplicated detector inputs and provide phase flow rates as outputs. It sounds easy, but it's taken years of innovative research, development and testing to achieve the accuracy and reliability that have made ROXAR today's leading supplier of multiphase meters. Here we see a ROXAR subsea multiphase meter and a ROXAR sand detector linked by a local jumper cable. The units can share power and exchange data. Let's look at some of the technology that lies behind the ROXAR multiphase meters. Detectors that measure electrical and physical properties in the mixture are used to determine the phase fractions. When water dominates the liquid phase, the meter uses conductivity measurements. When oil dominates, it uses capacitance measurements. Density of the mixture is measured using a gamma densitometer. The Venturi meter measures the mixture's velocity. Velocities of gas and liquid phases are also measured using cross-correlation to provide redundancy. All of these inputs are processed by an integrated flow computer which outputs phase flow rates continuously in real time. ROXAR meters use cross-correlation on signals coming from differently sized and differently spaced detectors. This allows them to measure the velocities of liquid and gas phases separately. This unique dual velocity method means that ROXAR meters measure phase slip directly and do not have to rely on model-based estimation techniques. So how does cross-correlation work? A property is measured by two identical detectors placed at two different locations, a known distance apart. As the flow passes the detectors, the signal pattern measured by the first will be repeated at the downstream detector after a short period, corresponding to the time it takes to flow from the first to the second. Many such readings are processed by the flow computer to calculate the time shift that gives the best match between the two signals. This time shift corresponds to flow time and is used to calculate the velocity. Where flow regimes are subject to large and rapid changes, ROXAR's dual velocity system ensures flow regime independent measurements. The space, weight and cost of a ROXAR multiphase meter is a fraction of what is required for a test separator doing the same job. And it needs only a fraction of the maintenance. For a multiphase meter that can do more for you for less, make sure it's a ROXAR. ROXAR has built up competence centres for sales and service around the globe. Our support engineers are ready to provide you with the best quality of service wherever you are.